Hey everyone, Kumar here. And the topic I wanted to discuss today is how to think about constraints versus objectives in an optimization setup. So when you're optimizing a product, especially in the fast-moving world of CPG, you're constantly balancing two forces. What makes the product better and what makes the product viable. In Bayesian optimization, we formalize this balance through objectives and constraints. Knowing the difference and using them correctly is the key to turning AI from a toy into a tool. Let's start with a conceptual distinction. So let's start with the core question. What are you trying to optimize? What can't you afford to get wrong? Objectives are the things you want to improve. You can either maximize or minimize them. Ask yourself, what would make this product better? So examples: maximize shelf life, minimize cost, maximize consumer liking score, minimize sugar content. Constraints are the rules you can't break. They keep you grounded in reality, safety, feasibility, regulations. So ask instead, what would disqualify this product from being launched? Examples: pH must be less than 4.6, must not contain peanuts, cost must not exceed 20 cents per unit, droplet size must be under 25 microns. Let's talk about it. Let's think of it as a visual analogy. Imagine you're exploring a 3D landscape, right? The elevation of the land is the objective value. Maybe it's flavor score or consumer liking. So the higher you go, the higher you climb up, the better the product. But there are fences and walls. These are your constraints. They define where you're allowed to walk. Bayesian optimization is your smart assistant, helping you climb the highest hill, but only inside the fences. Hope that makes sense. It's almost like climbing a mountain, but staying on the trail. If you go off the trail, you might not reach the top, but your goal is to get to the top, and the trail gets you there, but within the guardrails. So what are some best practices and guidelines around thinking about these concepts? So let's make it real with some guiding principles. Number one, you want to treat objectives and constraints separately. This is important because it prevents the system from wasting time on unlaunchable candidates. You want to use expert rules to define hard constraints. If you already know that something cannot happen, cannot work, is not viable, then you don't need to learn that, like safety limits or factory specs. Next, make measured outcomes soft if they're improvable. Don't hard limit liking scores, optimize for them. Things that can be improved should be maximized or minimized as opposed to putting hard limits on them. You can use penalties for soft constraints. You want less sugar, penalize it, but don't forbid it outright. You want to validate your constraints before running optimization. Garbage in, garbage out, remember that. So be sure your constraint logic is sound. You don't have conflicting constraints, your constraints are not infeasible, and so on. Use simulations or modeling, surrogate models for feasibility. If a constraint is expensive to test, learn a model of it instead, maybe, if you can. Now, that requires a lot of data to be in place, high quality data. If you don't have it, then this is not something that you want to start off right away. And use groups for scalable constraint design. So use tags like, basically create your groups of things you want to include or not to include in a particular group. How much of a particular group you want in a system, what should be the relative ratio between items in a group if you want to maintain some sort of a ratio. Any of these things can be expressed as groups, and define those groups and use them in your constraint design. So let's think of this as a decision tree for thinking, so we can think about this clearly. So I'll give you a mental checklist every formulator or data scientist should use before running the system. Is this a must-pass rule? Yes. Is it absolute? Use a hard constraint. Is it uncertain or noisy? You might use some other techniques, but don't make it a hard constraint. If it is not a must-pass rule, then you ask, do you want to increase it? Then maximize. Do you want to decrease it? Minimize. And if it's a soft rule, then you can use a multi-objective trade-off that the system will do for you. This way of thinking will keep you honest. It'll turn the business rules into AI-ready logic. So let's take a real world CPG example and then bring it all together. Let's say you're formulating a vegan dressing and you're told pH must be between 4.2 and 4.5. You must exclude all eggs and dairy. Cost must stay below 12 cents per unit. You want to maximize consumer liking and you want to minimize oil separation. So pause for a second and ask, which are the constraints? Which are the objectives? The constraints would be the things like pH between 4.2 and 4.5, a group constraint that says don't include ingredients that are known to have allergens, so exclude everything that's in that group that you create, and then core cost should be less than 12 cents. The objectives: maximize consumer liking, minimize oil separation. With that setup, the system will know where to explore and what to optimize for. So the system's not just math, it's a way to encode your business logic, formulation rules, and product vision into a living system. So you use constraints to capture what must not fail, use objectives to define what winning looks like, and use expert judgment to shape both. When done right, it's not just optimization, it's acceleration. Hope that helps. Thank you.